All right, next up we have Yuri, who is both a professor and an SRE at the National University of Columbia. And she's also an advocate for chaos, which is my absolute favorite kind of advocate. And she's going to be applying that chaos to Spring to show us the resilience vulnerabilities we may face.
Okay, hi, can you listen? Hi, good morning. Hi, everybody. Can I share my screen? Sorry, because I don't listen. Okay, thank you. Oh, let me share my screen. Okay. Hi, everybody. The title of my talk is Revealing Resilience Vulnerabilities in Spring Boot Architectures. Thank you. Thank you very much for joining us. Nice to meet you. Sorry, yeah. Nice to meet you. I am Yuri Niño. When I send this talk, I work as software engineer professor at the Universidad Nacional de Colombia in Colombia, and at this moment work as site reliability engineering for a company in Colombia that provides technology and innovation services. And I am chaos engineering advocate in my country. You can find me in Twitter, LinkedIn, and Medium as Yuri Niño. And this is my personal webpage when I publish my progress work about chaos engineering. They are the topics that I am going to cover in this talk. I am going to start telling you some sad stories from GitHub, Twitter, and Mexline. With this context, I am going to review some anti-patterns, patterns that could be useful mitigating these stories. In the middle, I am going to show a novel framework for practicing chaos game days using an awesome tool named Chaos Monkey for Spring Boot. Finally, I am going to share a demo using this tool. Recently, I was reading this book titled What Could Go Wrong. It is a fascinating science book that explains how we are still alive considering the chaos our bodies must face. We live in a dangerous world in which the genetic mutations, toxic substances, attacks by coronavirus and bacteria could kill us. Sorry, let me move this. Yeah. And let me go. Yeah. Probably you are wondering what is the relation with the topic of this conference. That I have found that this definition will apply to our software systems. If you use system instead body and chaotic instead dangerous, you could identify the adversities that our software systems have to face. Hard disk failures, network outages, unexpected customer traffic, and cyber attacks are included here. These scenarios will allow thinking in the things could go wrong when systems will be on production. So now let me remember stories that went wrong for some of the most important tech companies. I am going to start with GitHub. Probably you remember that in 2018, GitHub wasn't available for 24 hours when multiple internal errors resulted in an outage for GitHub Pages sites. Although the company has been working to build a resilient system. Lastly, we have experienced a lot of issues on production. Between June and July, GitHub were unavailable 4 times, which remember us that nobody is exempt from failing. So if we talk about security, generally the failures are caused by cyber attacks. which are unanticipated and catastrophic incidents. In this slide, some of the famous cyber attacks. Probably you remember to NotPetya. NotPetya was a cyber attack in 2018, which affected to all business units at Mexline, a famous shipping company. And a second famous cyber attack was experienced by Cartoon Network past year when a pair of hackers took aim at the cable network's websites across 16 different regions. And the recent cyber attack to Twitter, which exposed the accounts of most famous personalities in the social network. Twitter believes that attackers use social engineering to manipulate some employees to access the internal systems. The experience that has found many things will go wrong in the infrastructure and in the architecture required to deploy a software system. Incidents such as I reported have shown us any infrastructure is vulnerable to failure. The challenge here is that every production failure is unique. So there aren't two incidents that share the precise change of failure. Each architecture is unique, and they are as complex as the organizations or the users are using them. So here, a visualization of the architecture of Netflix and Twitter. So there are common faults that contribute to these failures. They are known as anti-patterns, and each of them can create or accelerate crashes in our systems. Let me review some of them quickly. Integration points, for example, are the number one killer of our systems. Everything in an integration project is a combination of HTML, front-end, APIs, backends, databases, and anymore. And there are two common anti-patterns in which we could fall into: the butterfly or the spider architecture or spider organization. So every single one of these fits presents an stability risk. Every socket, process, pipe, or remote procedure call can and will hand. They are illustration of these anti-patterns. And a second anti-pattern is node and slow responses. Slow responses usually result from excessive demand. When all available requests handlers are already working, there are no slack to accept new requests. Slow responses can also happen as a symptom of some underlying problem, memory leaks, for example. And I have good news for you. We can face them with resilience patterns. So I am going to review some patterns in order to face to these anti-patterns or these bad practices building architectures. If you are facing slow responses, for example, you can use patterns such as fail fast or timeouts. And in other side, circuit breakers are a great way. It is my favorite pattern. But in another side, circuit breakers are a great way to recover a system when you are in the middle of cascading failure or are a blocked thread. Here of my favorite pattern, another patterns, bulkheads and failpaths. In a ship, bulkheads are partitions that, when sealed, divide the ship into separate compartments, and a bulkhead prevents water from moving from one section to another. So you can employ the same technique by partitioning your systems in different parts in order to avoid this. So physical redundancy is the most common form of bulkheads. In the same manner, or in the same sense, if your system cannot meet your SLAs, inform callers quickly. So don't make them wait for an error message, and don't make them wait until they time out. That just makes your problem into their problem. So fail fast in this case. and the famous circuit breaker. In the energy industry, circuit breakers protect our houses from burning. So the principle is based in three states. Detecting excess usage, fail first, and open the circuit. More abstractly, the circuit breaker exists for allowing a subsystem, for example, in this analogy, electrical circuit, to fail from a short circuit without destroying the entire system in a house, for example. The same technique can be applied to software systems by wrapping dangerous operations with a component that can avoid calls when the system is not healthy, for example. So it is a review of anti-patterns and patterns, but we have a lot of common situations that could generate a failure in a system, and we have more patterns to recover a systems after these failures. So here I would like to remember that everything breaks, so faults are unavoidable. Simply avoiding these anti-patterns is not enough. Assume the worst faults will happen. And so we need to examine another ways to face them. So our proposal is using chaos engineering in order to test these patterns. So what is chaos engineering? Chaos engineering is a novel technique for experimenting failures in production in order to reveal their weakness and to build confidence in the resilience capability. I have highlighted 5 words that are valuable in the definition provided in the side principle of chaos: experimenting, production, reveal, confidence, and resilience. Experimenting is super important because this discipline is based on the method, on the scientific method, and confidence because it is about achieve resilience. And lastly, production, because the theory says that we should run our experiments on a production environment, although it should not be necessary so, but it is the definition. So now we have an additional focus for mitigating cyber attacks. So I am talking about security chaos engineering. Security chaos engineering is the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. I have highlighted 6 words more: security, failures, experimentation, confidence, and production. So this definition was taken from the last book published in April in this year. So the discipline is practiced following 4 principles. Hypothesize about the steady state. It could be difficult because probably you need a mature software and to be sure that your system is free from many bugs. And the second principle is vary real events. For example, change the values in a configuration file. And in a third principle, we have to run the experiments verifying hypotheses when servers crash. And finally, the idea is to automate these experiments using infrastructure as a code or another DevOps principle in order to automate these experiments. So chaos engineering can be automated with these tools. I am talking about Chaos Monkey. It was the first tool for injecting failures in order to generate resilience strategies. And a second tool is Chaos Monkey for Spring Boot. I am going to use it in the next slides in order to show you a demo using this tool. So we have another tools in the market: Gremlin, Chaos Toolkit, and Chaos Mesh. They basically offer features to break your systems injecting failures. So I am going to show you a demo in one moment. So how were we start this journey using chaos engineering? So using chaos game days. we started our journey practicing chaos game days. They are inspired in the classical game days created by Jesse Robbins when he worked for AWS. Game days are an interactive team-based learning exercise designed to give players a chance to put their skills in a technology to test. So in the next slides, I am going to share you a framework provided by Russ Miles. Russ Miles is the author of one of book for chaos engineering, and he provides a framework with 3 stages. So after that, I am going to share you a modification for this framework. So Russ Miles, his proposal was based in 3 phases: before, during, and after. Before, to run the experiment, we should focus on pick a hypothesis and a style, decide who, where, when, document, and get approval. During the game day, the idea is the engineers detect the situation, communicate, visit dashboards, analyze data, and propose solutions. And finally, the objective is to write a postmortem. A postmortem is a document that provides insights about what happened during the failure. And present solutions are actions that should be implemented after that in order to not repeat this situation in the future. So in our journey, we have evolved this framework, dedicated time to improve the method, integrate in pipelines, for example, automating the activities that we run in the first phase, adjust metrics, and something is very important here is validate our position in the chaos maturity model in order to improve our adoption of this discipline in our organization. So adapt next game day, and if we have the opportunity to explore this part, implement continuous verification. So in a 5th stage, we use an additional stage for automating. In this case, I am going to show you how you can automate this exercise using Spring Boot, using Chaos Monkey for Spring Boot, the proper tool or to interact with Spring Boot microservices, and Pulumi and Azure in order to pass the microservice to cloud. So it is the moment for our demo time. So I am going to share you a video with some activities for this. So this is the site of Chaos Monkey for Spring Boot, a library that allows us to integrate a Chaos Monkey for our Spring Boot. So, let me maximize them. So this tool is inspired by the principle of chaos engineering and the author's experience in distributed systems with focus on Spring Boot. With this, we can answer questions such as, will our fallbacks work? How does the application behave with network latency? What if 1 hour service breaks down? And if our service discovery works, for example, an Eureka, if it is okay. So this site provides reference of principles, foundations on resilience, and components that build the tool architecture. So also show us how to integrate the library in a POM file. If we are using Maven, for example, for managing our dependencies. And it is a command to run a jar for a microservices using, this is very important because we have to use this profile in order to run our microservice with this tool integrated. So next lines describes with detail how to can Chaos Monkey for Spring Boot interacts with controllers, repositories, services, and REST controllers. So they are the attacks available in the tool. So we can launch a latency assault, exception assault, app killer assault, and memory assault. So for this experiment, we are going to activate a latency attack using the proper configuration. So the creators have been passed by 9 versions, evolving awesome attacks and integrating the progress of the discipline. So they are instructions in order to integrate with Maven, this library. So if we click on a specific version, we have the possibility to interact with the reference documentation for the specific version. So, for example, we have an example of an application properties or an application YAML in our microservices implemented with the Spring Boot, with the lines for activating the Chaos Monkey and activated the profile in order to have the possibility to launch attacks such as, and for this case, I have enabled the attacks. They are the endpoints available. If you activate the profile and you run your microservices with this profile, you have these endpoints with the possibility to run Chaos Monkey configuration and verify the status of the Chaos Monkey if it is enabled or disabled. And this is the configuration for our test. So for this experiment, we built 3 microservices using a Spring Boot. Order service, in this case, order service, customer service, and product service. They are microservices implemented with the Spring Boot. So in this experiment, order service will consume customer service, and order service will consume product services. So in order to respond to a front end, for example, they are, in this case, customer service and product service are consuming a database named Chaotic, implemented or deployed with the MySQL. So they are registered in a discovery service named Discovery Service. And the code for these experiments is available in this repository, Learning Chaos Spring in GitHub. So for this experiment, we are going to test a circuit breaker configured between order service and customer service using the latency attack available in the Chaos Monkey for Spring Boot. The idea is to verify if the timeouts configured in the circuit breaker are working in a proper way. And the 3 microservices are consumed by a frontend built with Angular. It is a preview of this frontend. In this case, each div is connected with a backend, with a microservice in a backend. So in this case, we have a backend for authenticate a user, and we have the 3 microservices that I was talking in the previous slide. So in this case, we have order div connected to the order service, and when you click the div, in this case, this frontend show us the response and the time consumed by the request. So the code for this frontend is available in this GitHub repository. So here, the code and the configuration of each microservice. So in this case, we are seeing the microservices and the configuration in the application YAMLs. So in this case, we have the URL for connecting with a database. If you notice, in this case, we are using a URL in AWS in order to add latency, more latency, because our microservices will be deployed in Azure. So I have provided configuration for the Chaos Monkey. In this case, the Chaos Monkey is enabled. So they are the configuration and the URLs exposed by. So here, if you remember, our fifth stage is related to automation. So in this repository, I have provided the instructions in order to deploy this architecture in a cloud. using the proper commands for this. But so in this case, we have instructions in order to have a database using Docker, for example, and the instructions or the commands to build the project. So if we want to deploy them in Azure using the service for web applications, we can use these commands. And in this case, we are going to use a command in order to log in, in Azure CLI. So they are the environment variables required to run commands in an easy way. So we need a variable for resource group, registry, region, plan, and discovery, and the name of the application. In this case, I am providing the commands for deploying the discovery service. But the idea is similar for the another microservices. Remember, order service, product service, and customer service. The first step is to create a resource group. After that, we have to create a registry in order to register the comments, the applications. So after that, we need an Azure plant in order to have a space for deploying to the web application. So they are the commands. They are the commands required to deploy a service discovery in Azure. So I have provided them in the repository. If all is okay. If all is okay, when you go to all resource sections in Azure Console, we have the possibility to view or to see the plan, the registry, and the application deploy. So the idea is to repeat these commands for the another services. If all is okay, when we go to the Eureka URL provided by Azure, we can see the services available in that. So if you remember, we have to configure a latency times for our experiments. So I am going to providing 50 seconds for the first request, and this is the configuration for our histories. I am using histories as an implementation of the circuit breaker because that is the idea. So if we go to our front end, when we consume, for example, product or customer or order, we have the possibility to get the response and the response time. So when I consume customer.
Sorry, Yuri, to have to cut you off, but we do have very tight schedules, one of the unfortunate side effects of these virtual conferences. So thank you so much, Yuri. And we will be starting with the next subject really soon.